Hello everyone, I am Dr. Thiazole. I welcome you in my YouTube channel. Today in this video, I am going to describe about thiazole. You know my friend, thiazole is an important heterocyclic compound. You can see here the structure of thiazole ring. Thiazole's ring is a 5-member heterocyclic compound with 2 heteroatoms. First heteroatom is sulfur and the second nitrogen. So numbering always start with sulfur. This sulfur is the similar to sulfur present in thiophene, and this nitrogen is similar to pyridine nitrogens. So sulfur position 1, then carbon 2, nitrogen position 3, and 4 and 5 of 2 carbon. So there are 3 carbon and 2 heteroatom nitrogen and sulfur. Now you can see here unhybridized orbital, p orbital, and sp2 hybridized orbital. Now the properties like aromaticity. So there are some important points you can see here. Thiazole have 3 carbon as you have already seen, 1 nitrogen and 1 sulfur. All are sp2 hybridized. You know my friend, sp2 hybridization is planar. It makes a planar thiazole ring structure. Each ring atom also contains unhybridized p orbital, as you have seen just. That is perpendicular to the plane of sigma bonds, plane of ring. Here p orbitals are parallel to each other, so overlapping between p orbitals is possible. So total number of non-bonding electrons are 6, 3 of 3 carbon, 1 from nitrogens and 2 of sulfur. The resonance of 6 electron follows the Haeckel's rules. So all these conditions is found by the thiazoles. So it is aromatic. Now move to the synthesis. You can see the first method of synthesis, Gabriel synthesis. Gabriel synthesis is the condensation of acyl aminocarbonyl. Acyl aminocarbonyl compound in presence of phosphorus pentasulfide. You can see the reaction scheme. Alpha acyl aminocarbonyl compound converted into thiazole ring. Now mechanism. The formations of cyclizations and cyclic compound, and after dehydrations you can see the structure of thiazole. Now another method of synthesis of thiazole, Hansch thiazole synthesis from an alpha hydroxycarbonyl component. This is a condensation of alpha haloketones and thiamide. You can see the structure of thiamide in red and alpha haloketones. Why it is alpha haloketones? Because halo group present at alpha positions, referred to as the Hansch thiazole synthesis. Now you can see the mechanisms. First step SN2 type. Now you understand the SN1, SN2 very well because you have already read in semester 1. Then formations of this compound, it is converted into this compound and further cyclizations through nitrogen and carbon. So for bond formation between nitrogen and carbon. After dehydrations and E2 type reactions, you know the E2 type reaction eliminations, then finally you have thiazole ring. So this is a second method of preparation of thiazole. Now third method of synthesis of thiazole ring from iron thiocyanate salt. You can see here chloroacetone and indeed thiocyanate salt. Why it is salt? Because it is salt-like nature, positive and negative separation. In aqueous acid, dehydrations and removal of sodium chloride, you will get 2-hydroxy-4-methyl thiazole. This is the thiazole ring. Now my friend, reaction of thiazole is the first electrophilic addition to nitrogens. Protonation, which is basic properties. You can see here nitrogens provide lone pair of electron to hydrogens, which is H plus in aqueous acid. Thiazolium cation, which is resonance stabilized. N-alkylations with methyl iodide. You can see here formation of N-methyl thiazolium salt. Now electrophilic substitution to carbon. So favorable position 4 and 5. So if electron withdrawing group attach at position 2. So nitrations to amino 5-bromothiazoles. You can see here from 2-methyl thiazole it gave 2-methyl 5-nitrothiazoles and 2-methyl 4-nitrothiazole. Sulfonation thiazole 5-sulfonic acid from thiazole ring. Halogenations from 2-methyl thiazole to 2-amino 5-bromothiazoles. Now you can see the another reactions. 2-amino thiazoles undergo reaction with NaONO2HCl -5 degrees Celsius, thiazole to diazoniums, and further reaction undergo K plus chloride. It gave 2-chlorothiazoles. My friend, thiazole ring play an important role in synthesis of organic compound and medicinal uses. You can see here some important medicinal use of thiazole. H2 receptor blocker. H2 receptor blocker famotidine, nizatidine used in peptic ulcer. So nizatidine and famotidine both compound have thiazole ring. Chloromethazoles used as sedative hypnotics. So chloromethazoles also have thiazole ring. Vitamin B1, which is generally known as thiamine, used in thiamine deficiency. It also contains thiazole ring. So my friend, I hope this video will be helpful to you. So take your pen and paper, write it down in your notebook and prepare for your exams. Thanks for watching.